Welcome you all for myself Nagarajan, Assistant Professor in EC Department at Rohini College of Engineering and Technologies. In this video, we will see about the wavelength division multiplexing from the optical communication. So wavelength division multiplexing, after completion of this video, the student will be able to understand the wavelength division. See the wavelength division multiplexing, many different wavelengths between the 13,000 to 16,000 nanometer can be sent over a fiber simultaneously. It can be considered as a individual fiber lines shown in the figure. Optical multiplexer, we get a single fiber output. The technique of combining multiple wavelengths is called as a wavelength division multiplexing. Above figure is illustrate the concept of a WDM, wavelength division multiplexing. We combine together to make a single output. So different fiber lines of different data rates and different wavelengths are combined by optical multiplexer. All these wavelengths are available at the output. Wavelength division multiplexing. So let us see the wavelength division multiplexing scheme. So optical signals of different wavelengths can propagate without interfering with each other. So the scheme of combining a number of wavelengths over a single fiber is called as a wavelength division multiplexing. At the receiving station, an optical demultiplexer is required to separate the different carriers before photo detection of individual signals. The following figure shows the simple wavelength division multiplexing. To prevent spurious signal to enter into receiving channel, the demultiplexer must have narrow spectral operation with sharp wavelength cutoff. The acceptable limits of crosstalk is 0 -30. So this is the figure shows the wavelength division multiplexing. Here we are combined via transmitter is combined together. It is a wavelength multiplexer combined a wavelength and is given to a optical amplifier, and then optical amplifier is given to a receiver side that receive the optical amplifier, and next in receiver side we have a multiplexer, that is a wavelength demultiplexer. Here is a multiplexer, here is a demultiplexer. So each receiver receives the appropriate wavelength signal. Of WDM, important advantages of or features of WDM are mentioned below. Capacity upgraded, each wavelength supports independent data rate in Gbps, transparency and wavelength routing, wavelength switching. So transparency means it carries a fast asynchronous, slow synchronous and synchronous analog and digital data. Wavelength routing means link capacity and flexibility can be increased by using multiple wavelengths. Wavelength switching, WDM can add or drop demultiplexer, cross connects and wavelength converters. Types of WDM, so unidirectional WDM and bidirectional WDM. Unidirectional means unidirectional is used to combine different sources. Bidirectional means two or more wavelengths can be transmitted simultaneously in either direction over the same fiber. This is a bidirectional wavelength division multiplexing circuit. Categories of here WDM, it can be categorized in three categories. It's the coarse VDM, dense VDM, ultra dense WDM. I hope that all of you understood about this video. Thank you, dear students.